Welcome to part 2 of this video tutorial on coding a sniping bot. A sniping bot allows you to snipe the next 10x token at launch. If you enjoy this content, please like, share, and subscribe. That's how you can support the channel. Now, if you have been coding along with me, you're doing very well. I'm sure you've learned a lot. Now, if you have not been coding along with me, you need to open your PC right now and code along with me. If you have not watched the part 1 of this video series, please, the link is popping up on the screen right now. Go back and watch it. Don't just watch it, code along. That's how you build your muscle memory, and that's how you learn to fix bugs. Now, don't be surprised and don't be discouraged if it takes you days to fix the bug. Use AI, use Google search, because fixing bug, it's actually our work. It's the story of our lives as developers. So please don't be discouraged. You can even leave comments on this video regarding the bugs you're having, and I promise you I will do as much as I can to get back to you on that. It may take some time because I get a whole lot of comments. Please do well to check out our website, syncedgesolutions.xyz. Here you'll be able to explore our services and see all our other services. You'll also be able to schedule a call with us regarding any of our services, or even send email to us, and definitely we'll get back to you. Now, if you click view bots here, it takes you to our DeFi bots page. You can see different bots we have that are battle tested and they are production ready. The AI enhanced DEX snipping bot is the production version of the snipping bots we are coding. And basically, it doesn't just snipe new tokens at launch on Uniswap V2 and Aerodrome V2. It also runs a 10-point safety check on them to be sure that they do not have honeypots vulnerabilities or they are not scam tokens. Now, to be candid with you, 60 to 70% of new tokens being launched currently are honeypots or scam tokens. So this protects you from that. And so do well to reach out to us. Please do well to check out our recently launched pivot bots. It's already live on base mainnet. To access it, just come to the home page here and click pivots. Then it takes you to this dashboard. You can only see this dashboard if you have deployed your own bots, and it costs nothing to deploy your own bots except gas fees. So basically, pivot bots allows you to be earning yield on your leverage crypto trading position, unlike what you have on centralized exchange that you'll be paying funding rates for a leverage open position. Here, you will be getting paid, you'll be earning yield on your crypto trading positions, and you can access all the cryptocurrencies supported by Moonwell, because all we are doing is to use flash loan to amplify your position on Moonwell. So do well to deploy your own bots and check it out. So far, we have completed the step 1, which is list and watch a given DEX, in this case Uniswap V2, for the launch of a new token. We've done that. The second is for us to check whether there is adequate liquidity on the pool, and if there is, then we'll execute a buy order. That's exactly what this snipe function does for us. And this is the function we call to swap tokens on Uniswap V2. Now, the third step is what we are going to manage open position. So at this point, we'll have open position, and those open position will be on this inside this file, open trades. So we'll need to open this file to load open position, check the current price, and determine if it's time for us to sell or not. So I'm going to come here. The function we are going to write is managePosition. So I'm going to come here and let's write the function. So here is the arrow function named managePosition. After logging, let's check prices and managePosition. It's going to open the open trades file, and it's going to skip the first line, which is the header. Don't forget, our file will have the header as we did with this initialize CSV function. This initialize CSV function help us to put header on this open trade price and watch list file. So after that, and the next thing is for us to check whether we have open trades. If we don't have any open trade, which is this array open trades.length, we check the length of the array. If it is 0, we'll just we don't need to do anything because we don't have open trades. We still need to rely on Snipe function to dictate new tokens and make buy order. All right, so we'll just keep. But here, once there is open trade, then we have to do some things. Now, if there are open trades, this is what we want you to do. I need you to just give me 1 second to explain this. So, if there are open trades, of course, there will be many open trades. So, for each of the open trade, we want to check the price which the open trade is. So, if it has reached our target price, then we'll sell. All right. So, that's the whole point of this. So, if there are open trade for the first trade, our bots will come and load from this file. It's going to load the first line of the open trade file. And don't forget, when we were writing Snipe function, at the end of Snipe function in our open trades, is going to put all the data of the token it has just bought. It's going to append them. We have block number first, wrap the Ethereum address, token out price, the balance, and the price range label, which I'm going to explain very soon. Then the entry time in seconds. So all of this is what will be loaded from our .csv file. And so we'll have them, but the format will be in string. That's why you're seeing me casting them to number with this line. So this will be the token price in number data type. Then we have the initial token balance, we have the price range label, the token in address, the token out. After that, the next thing is to check whether the token we bought with sniped function here, whether we still have it in our wallet. Now it could be that we have sold it manually or we've transferred it out, but whichever way, we'll check our wallet for the balance of that token. So once we are going to log the balance out, that token in balance before, so before we do our selling, right? And again, as I said, every time you interact with the contract and you check balance, it will be returned in way. All right, so with precision, we are going to change the unit from way to ether by dividing it by 10 raised to power 18. So precision, if I go to precision here, is 10 raised to power 18. So basically that's what precision here is. All right, so then the next thing is, if we don't have the token in our wallet anymore, then we are going to delete it from the open trade files because we don't have it. So then we'll now move on to the next iteration, the next sniped token. All right, the next open trade, we'll move on to it. But if we still have it, then we are going to do the rest of the code. But before we move on, let me quickly explain the essence of this price range label. Yeah, so I'm just going to come up here. You remember I defined some parameters here that I said I was going to explain. Now, a very important one among them is this price range label. Now, you can see this array called TP factors. These are take profit levels, right? The first element in the array is 0.7, meaning that if our trade, the price is 70% of the entry price, we are going to sell. This is like a stop loss. So if we lose 30%, the bot will just going to is just going to sell. Now, the second element in the array to the end, these are the take profit levels. So if our trade moves 40% in our direction, that's 1.4x, is going to sell some of it. When it gets to 1.6x, that's 60%, is going to sell some. 1.8 is going to sell some, and 2 is also going to sell some. All right, now the amount it sells per time is this sell factor. So we have defined it to be 0.5, meaning that 50% of our current position will be sold at every take profit level. All right. But this stop loss level, 100%, all of our position will be sold. All right. So it does not, this sell factor does not affect this first one. That's how we are going to write it. Now, the whole point of price range label is this. Quickly, let's say the price, our entry price, the entry price, for example, the entry price is 10. All right. And let's say, so our stop loss here, as we have defined, is $7 because it will be 0.7 times 10 and it will be 7. All right. Now, and let me accept this because that helps us a lot. Our take profit one will be 14. Now, our price starts moving from 10, it gets to 14. 50% of our position will be sold. So let's say, and we know that price does not move in a straight line, it goes up and down, up and down. All right. So let's say it goes from 14, it gets to 15, and it comes back to 14. Without the price range label, when price gets to 15 and retraces back to 14, our bots will sell another 50%. Now, the price can also move again to maybe 15.5 without getting to this 16 and returning back to 14. Our bot will still sell again. So it's selling our position at the same price every time. So in order to prevent that, we want one sale to take place at this price, TP1, and it shouldn't make another sale again until TP2 is reached. So that's the whole essence of the price range. So the price range, let me label at this point, will be set to 1. At this point, it will be set to 0.8. At this point, it will be set to 0.6 and so on like that. So even if it returns without getting to 15 or 16, it returns to this 14. Our bot will check the price range label. If it is not 1, it's not going to sell. At that time, our price range label would have been changed to 0.8. So that prevents the bot selling at the same price. All right. Uh, let's come down here. All right. So over here, at this point now, this is what we are going to do. At this point, we are sure that we have an open position and we have tokens. That token we've bought, we have it in our wallet. So what we need to do now is to check the current price of that token we bought. All right. In order to do that, we need to call the Uniswap factory to get the pair address of the token in and the token out. Now, the token in is the token we have already bought. Don't forget, the whole essence of our managed position is to sell at the current, at the right price. So the token in will be the token we've already bought, and wrapped Ethereum will be the token out because that's the desired token we want to sell into, right? That's our balance. All right. So token in, token out, we'll get our pair, the pair address. So from there, we'll use it. We'll get the pair contract by putting the pair address and the pair ABI that we've gotten earlier and our wallet there. Then we can call getReserves on the pair contract. GetReserves will return an array for us. So the ratio of the two numbers it will return to us will give us the current price. So that's how we know the current price. Now, another way to get the current price is by getting getAmountsOut. So getAmountsOut is like simulating the swap you want to do. So we'll put an amount we want to sell in, and we'll also input the token in and the token out. Then it will return to us amounts we are going to get. Don't forget that's how we get our amount out. All right. So from that, we can also calculate our token in price, the current price of the token we want to sell. The current price will be in worth. All right. So both the two methods we are going to we are going to log our current price. I just like to use the two methods to confirm the price. So both of them must be in worth, the number of words we are going to get for 1 unit of our token. All right. So, and it's also going to log our entry price. By the way, in my last video, I went long on Ethereum and the price was around 1,851. Now Ethereum is 2,100. In fact, yesterday it got to 2,330. So I'm still holding on to it because I still believe the price will get to around 2,500. At that time, that's when I'm going to close my position here. So because what I did was that I supplied Lido stake Ethereum over here. Just come down here. I selected Lido stake Ethereum and borrowed Lido stake Ethereum against it. All right. So on my position, I am earning. If you come to Moonwell now, over here, I am earning. Here is the Lido stake. I'm earning 2.5% minus 0.6%. I'm earning about 1.9%. So and I used 4.5% leverage on this position. So 4.5 times around 1.9 makes me get over 8% APY on my leveraged open position. So I also noticed that Coinbase Ethereum, the supply, the supply APY on Coinbase Ethereum, let me come up here, is 7.5%. And the borrow APY on Lido is 0.6. So 7.5 take away 0.6 is 6.9%. So I decided to also get exposure to that too. And I used around 4 to 5% APY. So that also ensures that I'm on long position on Ethereum through that, although it's a very small position. You can see it here. But with that 6.9 times about 4x leverage takes us to about 24% APY. Now, most of the yield I'm getting is a Moonwell token, but some of it is in the base asset itself. So the base assets part is what you're seeing the average to be 0.15% APY. But if I want to get my well token, I just need to claim rewards here. So yeah, that's the situation. I mean, that's the updates regarding my position. If you come down here and you click this show strategy, it shows you the strategies you can also deploy. My plan is when Bitcoin gets to around $85,000 or Ethereum gets to around 2,600, I'm going to go short. I'll switch to short position. And to do that, all I need to do is to deposit supply. I will select supply USDC here and I'll borrow Lido stake Ethereum against it. So if I'm doing, and I also will probably use maybe 5x leverage, but maybe I'll probably use 2 or 3x leverage. So if I do that, you come to Moonwell here. If you supply USDC, your supply APY is 3.7%. Against Lido is 0.6. So net will be 3.7 minus 0.6. That's 3.1%. So if you use 5%, 5x leverage against it, it's going to take it to 5 times 3.1. That's around 15.5% APY. That's what you'll be getting. So that's what I'll probably go for. And yeah, again, most of it will be in Moonwell token, but some of it will also be in the base token, in the supply token itself. So do well to check out our pivot bots. That's what it does for you. It helps you to amplify your yield, your leverage, open position. You are always earning on it. This is unlike what you get on centralized exchange, where when you open a leverage position, you'll be paying funding rates to keep your leverage, to keep your trade open. Here, you'll be earning on your open positions. So, and it's also a leverage positions too. So do well to check out our pivot bots at syncedgesolutions.xyz/pivots. If it's your first time there, you would have to deploy your own pivot bots in order to see this dashboard. It costs nothing to deploy your own bots. It's just the gas fees, which is about 1 cent, 2 cents. That's what you spend to deploy your own bot, and you see this interface. Then you can now decide to supply to implement your strategies. Of course, as I've showed you, this, if you want to get more explanation, you'd see the strategies here. So do well to check that out. Now, once you deploy your bot, and you loop at least $10 on it, you supply at least $10 on Moonwell through PivotBot. Just copy your transaction hash and drop it in the comment section of my post on Twitter and on even Fakasta, whichever one you prefer. And I promise you, we will send back the money you've spent on gas fees and even buy you a cup of coffee. So we'll give you 5 USDC. It will be sent to your bot. So please check out Pivot Bots. Now you must have noticed that I used try and catch block here. This is to ensure that our code does not stop when it encounters an error. So when it's trying to swap or buy a token here, if there is error, it will just log the error for us here and continue to the next iteration. That's why this is quite important. So let's go to the next part of the code, which is when the price is in between our take profit points, which is between here and here. All right. So we are going to ascertain the exact points where the price is. So the token in price, if it's greater than one of our, we want to identify the exact CP points the CP factor is in. So if it's between 1.4 and 1.6 or between 1.6 and 1.8. So this does that for us. Then we'll check our price range factor if it's at the right price range. So it's not that it's coming to that particular price, that particular take profit point the second time. So we'll need that. Then we are going to check whether our holding period has not passed. So the current time must be less than our holding period. So then we are now, once all these conditions are fulfilled, then we can now execute this code. So we are going to log the particular take profit we are at. All right. Then here I made a mistake here. This is meant to be high, not 1. So the exact CP factor we are going to display it here. Then we are going to now get the new amount in the amounts we want to sell. Again, at that point, we are selling 50% of our balance. So you can see that's why I'm multiplying our current balance by the sell factor we've defined, which is 0.5 up here. You can see 0.5. So you can change yours to anything. Sorry. So over here, then the new amounts, we need to get the amount out as before so that we can calculate. Yeah, we can set our amount out minimum. So after that, we multiply it with slippage to get the amount out minimum. So with that, we can now call our swap token function that we want to swap, we want to sell. Then we pass all the necessary parameters. So after the swap is going to return the actual price. And with the precision, of course, we're going to take it to Ether from Way. Then we are going to check whether the transaction was actually successful. So the receipt.status will tell us if it's equal to 1, that means it was successful. Then our new price range label, we'll need to change our price range label because we have just done a swap, all right, to the exact one. Then these, we now have to delete, we now have to update our file, our .csv file. So with the right parameter for the swap we have just made. So we'll delete the existing one and we append the new one there. Now pause the video and try and copy all the code. That's why I'm scrolling so that you can pause and get the whole code. All right. Yeah, let me do this. So with this, we've been able to define our managePosition function completely. So I can now come down here and I'm going to uncomment it. Now, in this main function, there's something we need to do. So it will be done before our bot starts running. And it's for our bots to check whether we have enough wrapped Ethereum in our wallet to do to do the trade, to do the sniping. All right. So what we are going to do is with our wrapped Ethereum contract here, we are going to check our balance. So once we check our balance, if our balance is enough, because as we are buying new tokens and selling, our balance will change. So if it is less than, at any point less than the amount we want to buy, so here I set amount to buy to 0.03 Ethereum. I think that's about $10 or so. All right. So yeah, if it's less than that, then it will just add to our wrapped Ethereum. You remember when I was showing you wrapped Ethereum contracts on base scan, that it has a deposit function. So when you call that deposit function and you send a particular value of Ethereum to it. Yeah, I've not defined this worth amount. So I'm just going to come up here and I'm going to define the worth amount here. So this worth amount is the amount of our Ethereum we want to convert to wrapped Ethereum. So over here, we'll call the deposit function on worth contract and send a certain amount of Ethereum to it. So what it will do is to lock up our Ethereum, and in place of our Ethereum, it's going to give us worth. So it's always one to one. So if we send 10 Ethereum to it, it's going to send 10 wrapped Ethereum back to us. So that's how we are going to get worth. So after the transaction is completed, it's going to say got the amount of worth in our wallet, and it can now proceed as before and try to snipe. So the next thing is for us to test, because we are going to be running on base mainnet fork. We need to get the RPC of the mainnet. Well, luckily there's public RPC available. So if you Google base mainnet public RPC, you will probably get this one. So I'm going to include it in my .env file. So then there's another ritual I like to also perform. When I say ritual, I mean something I'm quite used to. So which is adding my Makefile. So I'm going to come here, right click and create a file. I'm going to call it Makefile. And you see how it works. It will help us to define our command. So I'm going to include this my .env here. My Hanvu will be a fork of the mainnet. Then I'm going to this should be my index.js file. And when we write our test, this is how we are going to run it. So every time I call make bot, is going to run node index file for me. All right. Now let's test what we have written so far. And we've written a whole lot. So I'm just going to come here. Here is the file index. Yes. Okay. So I'm going to press Command J now to bring up our terminal. And I'm going to come back to Makefile. Makefile is where our commands are defined. So I'm going to start up our local blockchain on Anvil. So I'm going to run make Anvil. So you can see our RPC node. You can see it's forked our RPC node, our base mainnet. So it's quite important that we are running it on the base mainnet fork. And the reason is that we want to interact with Uniswap V2. If you're not on the mainnet fork, Uniswap V2 will not be deployed on your blockchain. So you wouldn't have anything to interact with. That's why we are on base mainnet fork. All right. So on the second terminal here, I'm going to run the bot. The bot is node. To run the bot, it should be node index.js. But because I've defined it as bot on my Makefile, so I just need to run make bot and it will start it up. So you can see it went to get the worth that we needed for our transaction and it's listening. So you can see this is the transaction it made by calling deposits on our worth. This will let me quickly come back here. So if I can. All right, this was what it did. But so here you can see it said got this amount of worth. So this is it here. So and it started with trading bots. All right. Now it's listening for new tokens to be launched, but don't forget we are running locally, so no new token would be launched. It will just be listening indefinitely. So for us to test, we are going to create a strategy development mode. We are going to create a test mode, a test file for this particular situation, and we are going to test. We are going to try and create what happens on the live mainnet in order to test how our bots is working. All right, so let me stop this, and I'm going to minimize that. I'm going to come here, right click, and I'm going to create a file called test.js. That's where our test will be inside. All right, the first thing is our main function. We're going to call it here main. All right, so why do we need this file? Let's write our to do, what we want to do. The first is because this test will help us set up the conditions we'll have on the mainnet. So the first thing is to create and deploy a simple ERC20 token. We don't need to mint it. Yes, we'll do that locally. Then the second thing is to create a pair, a Uniswap V2 pair of it, Uniswap V2 pool pair for the token and weight. Yeah, so that this test file does not get confused with this test folder that we'll use in our Foundry. Let me rename this. I'm going to give it strategy developer. So let me give that name to it. Okay, I'm going to come to my Makefile and change the name of this to strategy developer so that it runs this. All right, now let's go to number 3. Once we create that, the next thing is to add liquidity to the pair. I'm not sure. Yes, that is not correct. So number 4 would be, so we add liquidity to the pair in the Uniswap V2 pair contracts. All right, number 4, then we'll need to buy the tokens in order to move price. So we'll have a new token in Uniswap V2 that our bots will be able to listen to. We'll have liquidity for our bots to be able to buy. Then we'll move prices, allow the price to change so that our bots would also be watching for the prices change and take profits or sell our position as at our take profits points, our take profit levels are reached. So that's what we want to do here. So let's define the things that we need. So I'm just going to come here and define the things we'll need. This is our blockchain data file, and we'll not need this. So let me delete this. Yes, these are the packages we'll need from ethers. Then our .env file. Then this wallet 2 would be one of the wallets here. I just press Command J to bring up the terminal. So on our blockchain here, let me stop the blockchain. If it's on Mac, Control C stops it. I'm not sure what stops it. The command for HP. for Windows. So yeah, here one of the private keys here, um this one, we'll take this one. All right, any one of them. These are the private keys, these are the corresponding accounts. So we'll take it and we'll use it as our default Anvil key. Instead of even calling it default Anvil key, let me call it Bob. Okay, Bob Anvil key. So the private key here, I'll come to my .env file and define it. Okay, so let me bring up the terminal again and copy this one. So any of it will do. I just don't want to use the same private key that I'm using in the bot as the one I'll be using to move prices. All right. So in the real life, there will be many market participants, those that are buying, selling, and your own bots too will be there. All right. Now you must have noticed that there is a parameter here, ERC20 bytecode. So here we are going to use bytecode to deploy our ERC20 token. So, and this is where our Foundry, the Foundry we installed earlier, is going to be quite important. So the first thing is we are going to come to this source folder. We don't need these contracts. So we are going to write a simple contract for ERC20 token. So I'm going to come here, right click, and I'm going to write a basic contract mock ERC20 token.so. Now inside this contract, that's where we are going to define our contract. Okay, let me make sure that it's the same name as the file we name. So this is a basic ERC20 token contract. You can see the constructor. The constructor is the function that runs at deployment of the token. So it takes the name of the token, the symbol of the token, and the total supply of the token. Then it's going to mint it to us with the sender. It's going to mint all the tokens to us. All right. Now you'll notice that this contract is inheriting OpenZeppelin ERC20 contracts. So it makes it a lot easier. This is a library that contains that has defined and created ERC20 token. So we just need to inherit it in our contract, and all the functionalities of ERC20 token will be available in our contract. So that's why our contract is so minimal and basic. So, but we need to install this library, OpenZeppelin library. Right, to install the library, I'm going to bring up my terminal again. I'm going to clear the terminal with Command K. So we are going to run this command, forge install OpenZeppelin contracts. So hopefully it runs. Yeah, it's going. Yeah. Yes. Now it has installed. So we can come here to our library, and this is the contract, OpenZeppelin contract. So if you come into this contract and you go into token, you see the ERC20 token here that we imported. This is the library itself. Let me minimize this so that you can see. So you can see all the functionalities, transfer from approve. Yeah. So we need to do one more thing again in our TOML file. So in our foundry.toml file, I just need to add this line. OpenZeppelin contract equals this. This helps us to define where our library is. All right. So anytime our contracts, our code C at OpenZeppelin contract is going to replace it with this location, lib OpenZeppelin /contract. So you can see that code at OpenZeppelin /contract. It's how we imported our OpenZeppelin. So it's just going to replace it with the definition here in the remapping. All right. Now, I can change this solidity version to 33 so that we'll stop having this yes, this error. Let's leave this as 0.8.20. Now let's come back. Let's come to the script folder. Again, we don't need this script. We need to write a new deploy script for our contract. So I'm going to delete this. Then I'll create a new file and I'm going to call it deploy ERC deploy mock ERC20 .s.so. All right, so inside the file we are going to write deploy script. Yes, so what we have here, as before, we'll define our Solidity version. Now we are going to import our contract here, mock ERC20 here, and of course this script from Foundry library. Then inside our deploy script itself, inside the contract, we are going to define the private key. The private key is, well, this thing. It's the private key that Anvil gives us. So let me just clear the terminal so that you'd see where I got the private key from. Yeah, so but normally it should be in your .env file, but we really do not need this, so that's why I can keep it like this. So this is the private key for this. So then after that, we have this run function that runs whatever is inside. All right, so here, this is the deployer key. Then this is our contract. Our contract has a constructor that takes name, symbol, and the initial supply. So in the deploy script, this is the name of the token, this is the symbol of the token, and this is the initial supply. You'd see the need for this as you proceed. Right, so let me ensure that I've named this file correctly. So rename, I'm going to change it .s. All right, now we are going to run this and deploy our contracts. This is up and running. Let me clear this terminal. Now I have commented out the private key. Let me just remove it. There are better ways to implement that. So it's not a good practice, so I'm not going to encourage that. All right, so this is our deploy script. Quickly, we'll come to this Makefile, and this is the command we are going to run to deploy our contract. So forge script, and where our deploy script is located is inside the script folder. We are going to be deploying it locally. You can see the RPC. All right, then the private key of the account we are going to use to deploy it. So this is it. Now this default Anvil key, I have defined it here in my .env file. Now how I got the private key is just here. Okay, let me start up the local chain again. All right, so the first private key here is what I use as the default Anvil key. All right, so now over here we can now deploy by running make deploy, and everything should work well now. It's saying we didn't use this, and everything has deployed. Because everything has deployed, we have this broadcast folder, and that's where we are going to get our byte code from. By the way, if you come to coinmarketcap.com/new, you see the list of some recently launched tokens. Um, a couple of days ago, I was scrolling down here, and this token jumped out to me. Clunch on number 32. If you click Clunch, it brings you to the detail of the token. Now, this is not me recommending this project. I know nothing about this token. This is just for demonstration purpose. So let's go on. Now you can see it's launched about on the 31st, that's about 3 weeks ago, and rose from about I think five times 10 raised to power minus 6, and got to as high as like 4 times 10 raised to power minus 4, made about 100x in a couple of days. So it got my attention, and so I decided to run it through our AI enhanced DEX snipping bots. So now we are going to need the peer address on Uniswap V3. We are going to need the token address wrapped Ethereum, the token is trading against. So over here, You can see it's on Uniswap V3. This is the peer address, the wrapped Ethereum, and the token address itself. Now we can start up our bot. npm start is going to ask for password with which I encrypted my private key. It has asked for it, so I'm going to enter that now. All right, so it's on and it's running. Okay, so now it's running the 10 points check to see whether this is a scam token or not. You can see the name of the token. All right, the token has passed, so it's meant to actually buy for us because the risk score is 0. So everything worked well. Let me stop it. All right, everything worked well. Let me just add this. Okay. All right, everything worked well. You can see all the analysis it has run, but now it's deleted it because something did not work well, and it's because there is low sentiment according to Grok AI about this token. So in the last 1 week or so, you can see the token has been going down. That's why. So the sentiment on it on X or Twitter is low. That's why it's not buying it. It has good liquidity because it has checked that, and yeah, everything works well. And it did a good prediction for the price too. So it was at a good level, but because of the fact that the sentiment is low on it, so that your money is not tied down, is not going to buy that. And that's basically how our AI enhanced sniping bot works. All right, let's get back to the video. So if we come to this broadcast folder and we'll select this. All right, so I want you to see this is the transaction that was sent to the blockchain. Now, this data, this input, this is actually the byte code that our contract was compiled down to, and it's what is sent to the blockchain. So this is what we need to copy everything. We'll copy everything. It's quite long. Yes. So that's what we are going to deploy in our Node.js. So I'm going to copy this and I'll come to the blockchain base file. This file, this is where we are going to now define our ERC20. I'm going to paste what I've copied here. Okay, without changing anything. Now let me get the exact name of that strategy developer. This ERC20 byte code. All right, I'm going to put the name here. Okay, I don't know why it keeps going back. All right. Yes. So we have our contracts byte code that we're going to deploy. So let's go back inside the file. Yes. Now we can now continue. Now we're going to come here, and according to our to-do, we are meant to create and deploy a simple ERC20 token locally. So we'll need the total supply that we want to deploy. We'll need the worth amount. When we get to that, I will explain that. But the first thing is for us to get worth, convert some of our Ethereum. Every dummy account that Foundry gives us comes with 10,000 Ethereum. Of course, it's dummy money. You can't spend that. All right. So then you can convert some of it to worth, which is what we did here, just as we did before. So we call the deposit function on it, and it changes our worth, our Ethereum to worth for us. Now we can now call the instance of this contract factory. You can see this ERC20 deployer is an instance of contract factory. It takes ERC20 ABI, and it takes the byte code of ERC20. Then it helps us to okay, so we can now call deploy function on it. Now you remember our contract over here as a constructor that takes name, it takes symbol and supply, initial supply. So that's exactly what we are passing in here. And this pass ether is what change our ether to way. So the total number we have here is in ether. We need it to change it to way. So that's why we are using pass ether function. All right. So yeah, Then we wait for it to deploy and wait 500 milliseconds after that. Again, as I explained earlier, this 500 milliseconds is quite useful because if you deploy things, when I was testing, if you deploy after you send transaction after each other, it mixes up the nonce in your wallet. So it's good you just wait for one to finish before you deploy another one. All right. So once we deploy it, it's going to log the contract address, the token address for us. Now, I noticed that we have not defined ERC20 ABI. So if we come here, when we deployed with Foundry, this folder was created for us called out. So if you come to this folder, you'll see this ERC20 folder. If you open this ERC20 folder, then you would see this ERC20.json, right? So this file contains the ABI. So it contains the ERC20 ABI. So this is the ABI. You can copy it. Once you copy it, we are going to come to our blockchain file. So which is down here. Okay, over here. And I'm going to come to just before this factory ABI. And I'm going to define everything there. This is our ERC20 ABI. Yes. Now we've defined our ERC20 ABI. The next thing is to come to our strategy developer file. And as our to-do says, we are going to create pair. So on Uniswap V2 factory contracts, we are going to call this create pair function. We'll pass the address of our worth and token address because we want our token to be trading against wrapped Ethereum. So we'll create a pair for both of them. Then, yes, after that, of course, we'll wait for the transaction to complete. Then our pair address, we are going to get the pair address we have created. So we are going to, this create pair, actually what it does is to deploy a contract that contains a pool of wrapped Ethereum and our token. So that's where the transaction will be taking place. So we are calling getPair to get the address of the contract created with this create pair. So we are going to log it, then we'll create the contract out of it. So over here, now in our to do, after we create pair, the next thing is to add liquidity. So we're going to come down here and we are going to approve tokens. So don't forget that because once we deploy our token, all the tokens minted will be passed to us. So we need to approve the router address to be able to take those tokens from our wallet. We'll also give it approval to take wrapped Ethereum from our wallet. So for the token, we'll be approving 10 raised to power 27 of it. That's 1 million in way. 1 billion in way, yes. And wrapped Ethereum, the amount of wrapped Ethereum that we want to also supply as liquidity. Yeah. So after approving, then we are going to call this function that we've now written, which is the supply liquidity function. So let's now write the supply liquidity function. So up here, I'm just going to define the function there, supply liquidity. So you can see we are calling add liquidity function on the router contract. It takes the tokens, wrapped Ethereum and our token, and the amount of them we are passing. So you need to pay attention to this token liquidity factor. It's just, I have defined it up here. The token liquidity factor is defined, and here I set it as 100,000. Now let's follow it over here in the supply liquidity function. So you would see that this amount, which is the input amount, is actually the amount of worth we are going to supply as liquidity. Now to get the amount of the token, the deployed token that we want to supply as liquidity, we'll just multiply token liquidity factor by the amount of worth. So if you remember over here, when we're calculating the price, So what we did when we're getting the price is the ratio of the reserves. So you can see that's how we calculate the price. So for us to get for the price, the initial price in the pool to be a certain amount. So that's why I'm using token liquidity factor. So the token liquidity factor at this time, because it's 100,000, the price will be starting at 1 over 100,000. That's 10 raised to power minus 5. So that's the whole essence of that. If I change it to 10,000, then the initial price in the pool would also be 10 raised to power minus 4. All right. All right. So these are the parameters we need to pass to this liquidity transaction. Then we also wait one block for the transaction to be completed. I defined the deadline here. It's 10 minutes, and our wallet. We also pass our wallet into it. All right. Then we are going to log liquidity added to the pair as ratio 1 to whatever the token liquidity factor is. So in this case, 100,000 as we define it here. All right. So since we have defined the function completely, now we can come here and uncomment it. Now let's get back to our to do over here. After we had liquidity, the next thing is to buy tokens in order to move price. So we want to move price now. We will now come down here and move price. So we are going to log let's move price. Here we are buying. So you can see I'm calling swap exact tokens for tokens, and we are buying the token with wrapped Ethereum. So we pass the amount of the worth we want to pass in to buy the token. We also have the amount out minimum. Amount out minimum because we are on the local testnet here. I just define it to be 0. All right. So 0 n. N there means that it's a big number. All right. Then so we have the input token is wrapped Ethereum. Our token, the deployed token is what we are going to get. And our wallet and the deadline we've defined. So we'll wait one block for the transaction to complete. So after we buy, we'll also wait 10 seconds before making the next purchase. That will give our bot sufficient time to see the price. And if the price has reached the target, then it can also buy. So this is how it works. And we are going to buy 9 times. So every time we buy, we are buying amount to buy. Let me just go up. We are buying 10. Yes, 10 worth. Yes, we are buying 10 worth of equivalent of token, the deployed token. That's what we are buying every time. So that will ensure that the price will be changing as we are buying. So as we are buying, the quantity of the tokens we have in the pool will change, and our wrapped Ethereum too that we have will change. That ensures that the ratio of our token to wrapped Ethereum will be different, and that means the price is changing. So all we are doing by buying is to move price. So that means we will be buying 10 worth equivalents of our token every at every iteration. All right, I think we finished now. So let's now test our strategy development mode. I press Command J to bring up the terminal and Command K to clean the terminal. So I'm going to do the same thing here. Control C to stop this from running, and Command K to clean it. So I'm going to start the terminal again by running make anvil. All right. So these are commands. I'm bringing that up. Make anvil. Now I'm going to the second terminal. I want us to run this strategy developer code. So I'm going to run make test, and let's see if it works well. For a strange reason, this test keyword seems not to be working. So I'm going to just change it to dev. So if we want to run, we'll just run make dev. All right. So I'm going to start up the blockchain again, make anvil. and it's up and running. Then I'm going to come here and I'm going to run make dev just to run only this strategy mode, and it has started. It got 8,000 worth. It has deployed our test token. Yes, this is the contract address of our test token. This is the pair address of the test token. Yeah, when we created pair, the new pair contract is this worth and tokens approved for the router. It's been approved. Then the liquidity has been supplied here. Now it's moving prices. So he's buying. He bought the token for the first time. See what is logging here. Bought some token one. Bought the second time. The third. So after every buy, is waiting for 10 seconds before buying the next. So it's bought the fourth one, the fifth. I can go on and on, but let me pause because we are going to test everything again with our bots listening. So I'm going to stop it here, and Command K will claim our terminal. I'm going to stop, so you can see many transactions that have gone through our blockchain here, our local blockchain. So I'm going to stop it. Control C, Command K cleans it up. All right, so let's come back to our bots now. Over here, let me minimize this. Okay, so we are now ready for the integration test. I need to open this down, our watch list. We also need to have this file open down, because when we have open trade, this is where we will track it. Watch list is when a new token is launched. This is where it's going to put it. So and this one too, to help us to know what to run. All right, so moment of truth, I'm going to run make anvil to start up the blockchain. It's up and running. The next thing is to make sure our bot is running. So I'm going to run make bots in the second terminal, and it will be watching and listening. Then we need to open the third terminal. That's where we are going to run make dev. So make dev, it's up and running. Our watch list is here. Let's come here. It has detected what has just been launched and it has bought. So let me come to open trade. It has bought. You can see the price label is one, and it keeps changing and moving here. Need to keep up. So you can see it's displaying the checkpoints and checking the price. It has reached 1.4x and it has sold. You can see it has changed. The price label has changed. So it's moving again. And 1.6x price has reached and it has sold again. Yeah. So it's still monitoring. You can see here. So you can see every 33 seconds is checking the price. So swap token getting out of the position completely because the price has reached 2x. So it has sold. So you can see this has disappeared. It has cleaned our open trade file for us. And at that time, this is still selling. Yeah, this is still selling, but the price has passed 2x. If I'm able to, okay, let this finish, then I'll come back here and see if I can get the entry price so that we can do some analysis. Okay, this has finished. I'm going to come here now and let me maximize the terminal so that we can see what has happened here. Over here, this is when it's reached 1.4x. I want to see the entry price itself. Okay, this is our entry price exactly. So it's actually bought when we have 0.0 in four places 1. Then when the price got to 0.4 places, that's 10 raised to power minus 5. 1.4 times 10 raised to power minus 5, that's 1.4x. It's sold. Yeah, that was quite accurate. Then 1.6x is when the price reached 1.6 times 10 raised to power minus 5. It's sold. All right. Then the final selling, let me check, getting out of the position completely. This is it. When, yes, you can see the price is now 2.2 times 10 raised to the power minus 5, which is more than 1 times 10 raised to the power minus 5. So that was why it sold. This was in accordance with what we wrote here. So let me minimize this. TP is 2. So everything has worked very well. That's excellent. If you have made it this far and you've been writing the code with me, or you are still fixing some bugs, congratulations, because you now have a very useful tool with which you can snipe the next big token launch. Feel free to be creative with the tool. Try and extend the functionalities of the bot. Integrate new dexes like Uniswap V3, Uniswap V4, Aerodrome V2, even Pancake Swap. Just be creative with it, but don't forget the security aspect of the bot. If you're interested in production ready snipping bots, check out our AI enhanced snipping bots. It ensures that you are protected from scam tokens and honeypot attacks out there. Also, check out our pivot bots that we recently launched. Basically, it helps you to amplify your yield on Moonwell and also ensure that whether your crypto trade is long or short, you are earning yield on it. So this is unlike what you get on other exchanges that when you open a crypto leverage position, you would have to be paying funding rates. With pivot bots, you earn yield instead of paying interest rates on your crypto trade position. So make sure you check out our pivot bots. All of these are available on our website, syncedgesolutions.xyz. Please don't forget to like, share, and subscribe. That's the only way you can support the channel. And as I always say, every time you see my video, you will always learn something new. Thank you so much, and I'll see you on the next one.